Massive volcanic blast in the Pacific last year was felt 18,000 kilometers away on the other side of the world, on the floor of the Atlantic Ocean. The cataclysmic eruption of Hunga-Tonga Hunga-Ha'apai on the 15th of January 2022 sent pressure waves through Earth's atmosphere that connected with the sea surface and triggered 50 highly sensitive seismometers placed 5,000 meters underwater on the seabed. It was one of a number of intriguing phenomena picked up by the instrument network in the Azores-Madeira-Canary Islands region. Scientists, led from University College London, had set up the stations primarily to detect earthquakes. The goal is to use the signals from ground motions to image the interior of the planet, to trace the great upwellings of magma of the type that built the islands of the Portuguese and Spanish archipelagos. Sensing a far-off volcanic eruption through an atmosphere-ocean interaction was unexpected, as was the detected cacophony of whale song and the explosive sinking of a cargo ship carrying some of the most luxurious cars money can buy. The volcano signal is interesting because it neatly illustrates the power and reach of the remarkable Pacific event. Hunga-Tonga produced the highest ash cloud ever recorded, sending rocky particles more than halfway to space. But the energy involved also shook the atmosphere, dispatching so-called lamb waves in all directions. These are energetic waves in the air that move at the speed of sound, along a path guided by the surface of the planet. Over the eastern Atlantic they produced pressure changes that were transmitted to the seabed. Because the pressure disturbance only moves at 330 meters per second, it takes a while to move across the network, producing the gradient, or slant, in the chart. The upflow seismometers were in position on the Atlantic Ocean floor for 1 year, ending in September 2022. The submerged instruments carried onboard data loggers, which meant scientists had to recover them to access and analyze their information. These big tremors can act like a strobe light to illuminate the interior structure of our world. The scientists want to investigate the plumes of hot rock that rise up from deep, and which, when they breach the crust, will result in volcanoes. Plumes have also been responsible through geological history for some of the greatest ever outpourings of lava. In Siberia and India, there are regions where hundreds of thousands of cubic kilometers of molten material spilled across the land surface. Its siting was close to the mid-Atlantic ridge where some of Earth's tectonic plates meet. The nearby continent of Africa would also influence how plumes would flow. The upflow team hopes to publish its imagery in the next couple of years.